Hello. Yeah, welcome to chapter 12, which covers compound interest and present value. Now, the goal of this chapter is to be able to compute what we call the future value and also be able to compute the present value. Now, we use the compound interest concept to be able to understand the future value. And you're going to see how this works out. So I'm going to spend some time just to give you a conceptual view of the chapter in this part of my video. And then in the second video, which is part two, will be to walk through a number of problems by applying some of these concepts. So just to understand some of the concepts in the chapter, when we talk about compounding, what we mean is computations or calculations of interest periodically over the life of the loan or of this could be an investment. So in other words, we're trying to get to the future value. And therefore, the future value minus what was the initial value of the investment should give us the interest that has been built over time over that particular investment. The compound interest is the interest on the principal plus the interest of prior periods. So in other words, this is different from the simple interest as we saw in a previous chapter. With a compound interest, you basically earn interest on your initial investment and you also earn interest on your prior earned interest. So you earn an interest on interest, in addition to that, also interest on your initial investment. The future value then is now what has been compounded. So you're looking at your initial investment, and that initial investment has been earning interest, and the same interest has been earning also interest. So if you look at the growth of that becomes the future value, so it's the final amount of the loan or the investment at the end of the investment period. So if you invested amount for let's say 2 years, so it will be how much you invested initially, and then the interest that you earned in year one, plus of course the interest without you recouping that money, without you taking the investment at the end of year one, you leave it. But remember, the investment at the end of year one has already earned interest. So you're going to earn interest the second year on your investment. In addition to that, also on your year one interest that you have already earned. The present value is the value of a loan or an investment today. So it's basically the opposite of the compound amount or the future amount. So really, what we are referring to, if you think about it, so if you look at an investment, so let's say you invest $100 today, and you invest this for 2 years. So this is end of year one, this end of year two. So we know that this is your present value. This is how much you're investing today. So this will represent the the present value. But this $100 you're investing today, and assuming you're doing this at 10%, so if this investment was 10% per year, if you think about it, and this is basically your rate. Your I is 10%, and the number of period could be 2 years. So in other words, how much are you going to have? What will be the compounding? The $100 will grow to how much at the end of the 2 years. So in other words, then we're talking about the $100 growing into sometimes in the future. Again, you're going to see how we compute or how we arrive at the value. But simply put, I will tell you is that the future value. So this is going to be a future value, or is going to be the compound amount. So either you refer to it as compound amount, or we refer to this as the future value. So our future value then it will be the how much you're investing today. So it's going to be your present value, the $100, into 1 plus I and raised to a number. Again, we're going to see how this works out later on, but just to give you a quick overview, this amount will grow to a case of you're putting $100 today at a rate of 10%. So 1 plus 10% will be 1.10 and raise this to basically 2. Now, if you think about it, the 1.1 raised to 2, you know this very well, this will be a 1.21. So in other words, this value is same as saying $100 into 1.21 times 100. This will be 121. So in other words, the $100 invested today will grow to $121 at the end of 2 years if the terms of this investment is you're being given 10% interest or you're earning 10% interest, and this is for a period of 2 years. But again, we're going to see how we get there. I'm just showing you a quick overview of the concept, what we mean by the present value and the future value. So the present value in this case is $100, and the future value, of course, is 121 is the future value. So let's assume. So let's assume you're not being given this, and you're given the future value is 121, and you're being asked to determine, of course, the present value. Then again, you basically use the same formula and reverse it. So your present value will be, of course, your future value into 1 plus I raised to n. And again, if you think about it, it will be the same thing of saying my future value is 121. We know it's 121. So if my future value is 121 and my rate is 1 plus I, we know that I is 10%. So it's going to be 1.1 raised to n, and we know n is 2. So this will be the same thing of saying 121 over 121 over 1.21, and this will give you the same thing of $100. Again, we're going to explore how we do this later on. The objective of this explanation is just to understand the concept. Now, there's one thing that is important when it comes to the present value or the future value, and that is the compounding terms. So in other words, the terms of the investment or the terms of the loan could be you're being offered an 8% per year or 10% per year. So if the terms are if the compounding is on an annual basis, is every year, so once a year, then if you're talking about 1 year, then you have one period. If you're talking about 2 years, then of course you have two periods. If you look at 5 years, then you have 5 periods. However, if the compounding is on a semi-annual basis, which is in this case could be is every 6 months. So in other words, then if it's every 6 months, so this was a case of semi-annual, right? So in other words, and you have an investment that is running for 2 years, year 1 and year 2, then it means you're going to earn interest every 6 months. So it means this is period 0. The first 6 months you have earned interest, the next 6 months you earn interest, and the next 6 months you earn interest, the next 6 months you earn interest. In other words, you end up having how many compounding periods? It's not just 2 years. The compounded periods is going to be 2, and you have 2 periods per year, do about 2 years. So times 2, you'll end up having 4 periods. If it is a case of 2 years. If you're just investing for 1 year, then you'll have 2 periods. Compound on a quarterly basis, again, is going to be every 3 months. So what you end up having is, if this is done on a quarterly basis, so what you'll see is every 3 months you earn interest. The next 3 months you earn interest. The next 3 months you earn interest. The next 3. So in 1 year you'll end up having 1, 2, 3, 4 compounding period. Again, that's where the 4 is coming from. Again, in 2 years, then you'll have 2 years times how many compound periods per year. you have 4 per year times 4, you end up having a total of 8 compounding periods, again, over 2 years. It was this a case of 3 years, then it will be 3 times 4, then you end up having 12 periods. If this is done on a monthly basis, then we know that we have 12 months in a year, and therefore in a year you have 12 periods. If you had 2 years, there will be 2 years times 12, you'll have 24 periods. If this is done on a daily basis, then we know that we have 365 days in a year. So in a year, you end up having 365 periods. If it's a case of 2 years, then it will be 2 times 365, and that will be the number of periods you're going to have over a 2 year period. Now, this becomes key to us. And again, you're going to see this, why I'm trying to emphasize that if you really have to understand the compounding periods, because that is key to solving the present value or the future value problems. Likewise, when it comes to the interest rate, again, that will also help us. For example, if you are being given, I just to show you again, the rate is also very important, or the I is important. So again, if you're being quoted on 10% per year, right? But we know that the number of compounding is on a semi-annual basis. So if this was a semi-annual basis, then we know that we need to determine the rate per period. So if you had a case of 10 years, 10%, and you have 2 periods per year, then the rate per period is going to be 10 divided by 2. So you have 5% per period. And the same thing, if this was a case of quarterly, again, you do the same thing. So you really have to determine what is the rate per period and what is the number of the component periods that we have in a particular problem. And this basically demonstrates the point of what we're trying to say here is, in trying to determine the future value, again, I just showed you earlier on using the $100 as the initial investment and try to determine the future value over 2 years. In this example, you're being given, you invest $1 today over 4 years at 8%. At 8%. So how much value, the future value will be at the end of 4 years using those particular terms. So in this example, again, you invest $1 at 8%. This will end up being 1.3605 at the end of 5 years. So you'll have earned interest on interest on interest. So at the end of year one, it shows you at 8%, you invest $1. At the end of year one, you have $1.08. And then this amount will also earn interest. And so you earn interest on that $1 and also on the 0.08. So at the end of year two, you have now 1.664. At the end of year three, that amount also earns interest, and you'll have 1.2597. And at the end of year four, you'll have 1.3605 as your future value. So this is now the compound amount, the future value. This is the present value at time 0. So today, the value is $1. This amount will grow to 1.3605 in 4 years, where the terms is 8%, and the compounding here is per year. So it's 8% per year, and you have 4 periods, and the rate is 8%. Now, remember, if this was a semi-annual case, then the terms are going to change. So if this was a semi-annual, then what you're going to see is a case where the rate is no longer 8%. The rate is going to be 8 divided by 2 periods per year. So your rate is going to be 4%. And the number of periods, the N, is no longer 4 years. The N will be 4 times 2, which will be basically 8. So you end up having 8 periods, and the rate will be 4%. And you can use those terms to compute the future value. Again, the future value is going to be different. Most likely, this future value under these terms, the future value, is going to be greater than what you're seeing here, because here you're earning interest every 6 months. You'll have earned more money at the end of 4 years under these terms than if you're using the original terms we have here to get to 1.3605. Again, we're going to see this later on how we can compute this. So I won't spend time in trying to show you how we compute this manually. Just to demonstrate the point is, at the end of year one, you're going to earn interest, and the interest you have earned in this case is the 0.08, and the end of year two you'll earn. So again, it's just an intensive process to try to do this the manual way. So the only best way is to use the other ways we can do this, which I think it's better for me to highlight some of these issues. Now, to try to determine the future value or the present value. So we can determine this based on what you've been given. There are several tools we can use, and I think I mentioned this in my earlier discussion, that we can use the what you call the financial tables, which is basically the focus of the chapter. Is they demonstrate on how we use the financial tables to find the future value and the present value. And I'm going to show you how those tables look like. The other way to do this is to use the financial formula. And this is just basically the one I showed you earlier. You might be wondering, where was I, using for example, the one I said before was to determine the future value. Remember I said is you'll take the you'll take the present value times the 1 plus I raised to n, where I is the rate per period, and of course n is the number of periods. Of course, to determine the present value, you basically do the inverse of this. So basically, the present value will be the future value divided by into 1 plus I raised to n. Again, we use the formula to determine the future value or the present value. Okay, it depends on what the question is asking you to find. Another way to do this is to do the manual way, which is basically what is being demonstrated here. So you can do the manual to determine the future value, which will the future value will be that. But again, this is a very tedious process, assuming you have 20 years to deal with, or 40 years or 40 periods to deal with. So it won't be, you won't be able to do this, from year one to year two over 20 years. That's why, again, this becomes a tedious process if you try to do it the manual way. The other way to do this is to use a financial calculator. And another way to do this is to use, of course, spreadsheet Excel. So again, either method will try to give us an approximate answer. I can't say it's going to be the same because the focus of the chapter is on the use of the financial tables. So I will emphasize or stress that you try to stick to the financial tables. But it's also very important that you try to practice on how you can use the financial formula, how you can use the financial calculator, and how to use Excel. Because you're going to see the knowledge that you're getting in this chapter is going to be crucial in other courses, especially in accounting and also in finance. So again, knowing the other methods or the other techniques is crucial when it comes to those issues. So those are basically the tools. Again, keep in mind, knowing the number of periods is very key. Knowing the rate per period is key, and that will help you in trying to solve the problem. So know how many periods are we referring to. Make sure you understand the number of periods. Again, if it's a yearly basis and you've been given 2 years, we know the number of periods is 2 years, and if the rate is 10%, it's on a yearly, compounders are done on a yearly basis, then that doesn't change. It's still going to be 10%. However, if this was done on a semi-annual basis and you've been given 8%, then we know that the rate per period is going to be, of course, 4%. And the number of periods, then in 1 year, you have 2 periods per year. So you end up having 8, we were talking about 2 years. So just make sure you understand the number of periods, and of course to understand the rate per period. So again, that's very crucial to us when it comes to solving or computing some of those problems. Now, this slide basically captures, the difference between what we saw last week, because our focus previously has been on a simple interest, which basically, again, the formula is the PRT. You take the principal times rate times time, that gives you the interest. Compound interest formula is different because, again, remember, you're earning interest on interest. So to determine the interest element of it, we take the future value. So we just take the future value minus, of course, the present value, and this will give us the compound interest. Again, you're going to see that the number is going to be much bigger than in the case of a simple interest. But that's how we determine the interest element. So a good example of this is this. So you invest $80 today. Over 4 years, this amount grows up to 108.83. So then, of course, this is the future value and this is the present value. So this is how much you invested initially. This amount at the end of 4 years, that amount is 108. It means then you take the difference between the future value, which is that, and the present value, and this just represents the cost of the investment or the cost of borrowing. So your interest is basically $28.83 if you have to use that example. If you use the same example here in terms of the present value, and you invest in $80 for 4 years at 8%. In this example, your interest is 25.60. So you'll see there's a bigger difference between the interest here and, of course, the interest here. With a compound interest, your interest is going to be higher than under simple arrangement terms. The maturity value, this example becomes 105.60. The maturity value, which is the future value under this arrangement, is going to be 108.83. So that's basically the difference between the present value and the future value. Now, I just want to spend some time just to show you how we use the tables, because I remember what I said was the text tends to focus more on how to determine the present value and the future value by using financial tables. So we're going to show this. But remember, we're going to use the same knowledge we said before, that we need to understand the number of periods in the problem. We need to understand the rate in the problem, and then the rest is just to pick up the what you call the table factor, and we use the table factor and either multiply this with the initial investment, and that will give us the future value. So in other words, if I can just show you with the use of the financial formula. So we know that what I told you before was that future value will be equal to the present value times 1 raised to power of n. And I used the example of $100. So 100 represents the initial investment. And we said if you take $100 is your initial investment to represent, of course, the present value, and your I is 10%, so that would be plus 0.1, and raise this to n, and we say that n is 2. Assuming n is 2 and assuming I is 10%. If that was just what we're referring to here, we know that then that this will give us $121 as the future value. So in trying to use the table is the same concept. So what we know that we know n is 2 and I is 10. So we will use this and go to the table. So what the table is going to give us is basically this value, the 1.1 raised to 2. So the 1.1 raised to 2, which comes to 1.21, this is what we call the table factor. This is what your table is giving you in the case of the future value. So the table is basically giving you this, which is basically, again, in this example of n is 2 and I is 10, the table is giving you 1.21. And then you will take that table factor and multiply it with the present value, which is $100, and that will give you 121. Again, the answer, you know, might not be the same, but it's going to be an approximate or close answer. So you might have, because of rounding effect, it might not be exactly the same, but it's going to be close to the same, depending on the method that you're using. So if you're using a financial formula like this one, you might get maybe the same answer, or not the same, but close. So to use the tables, then the table shows you this. It's just to give an example of a future value table. And this is, again, the different types of financial tables. There's a future value table for $1. There's a present value for $1. Then there's a future value for an annuity, owner annuity, and also. We're going to see this later on in the course when we get to the next chapter, where we have to deal with an annuities. In this example is just what I just told you. If I can still use the same example of an investment of $100 today at a rate of 10% for over 2 years. So in this example on this side you have the number of periods. And this is just basically a partial table giving just 15 years, but you could have more than, or 15 periods, but you could have more than that. And then on the top right, you've been given the rates, the percentages. So in our example, we're talking about 10%. So we have 10% is our example. And then we are looking at our initial investment for 2 years. So you look for 2 years and you look for 10%, and you just walk it at the line where the two intersect, which is that. That becomes the table factor. Again, you can see here the table factor is 1.21, which is the same thing I have here is 1.21. So that table factor, you'll take the table factor and then you multiply it with the present value, and that will give you the future value. So in this example, you take 1.21 times the present value. If I use the previous example, our present value was 100 times 1.21, and that will give you 1.2100. So in that example, no, it would be that'll be 121. So there'll be 121.00. So that becomes the future value. Again, it's the same thing as just this problem. Again, the key idea is, in this example, I'm assuming the compounding is done on a yearly basis. However, if the compounding was done on a semi-annual basis, then that will change our approach to the problem. So let's say this was with the same problems, the investment is for 10% per year. So this was 10% per year, and our rate here was our number of periods was for 2 years. Investment was for 2 years. Then this will change our number of periods. So our N then is going to be, because it's on a semi-annual basis, every 6 months you earn an interest. So we have 2 periods per year. So you have 2 periods per year, and we're talking about 2 years. So your N ends up being 4 years. And your rate per period is no longer, as we saw, because it's not on an annual basis, it's on a semi-annual basis. So therefore, your I, or the rate, changes from 10% to how many periods per year? 2 periods per year divided by 2. And in this case, you end up having 5% as your rate per period, because you have 2 periods per year. So in this example, then you end up taking the 5%, and you'll end up taking the number of periods of 4 periods, 4, and then you walk through 4 and 5, and that example, then your table factor will end up being 1.2155. So if you're looking at the future value using this example, your future value then will be the present value times the table factor, the future value table factor or interest factor. You find some books call it the future value interest factor. So your future value interest factor is the 1.2155 times your initial investment is $100. In that case, then you have 121.55 as your future value or the compounded amount. So again, you can see you have some increase is more than the 1.2100. Here you end up having 55 cents more by doing a 6 months or a semi-annual investment than doing an annual investment. If you do this again on a quarterly basis, you end up having a different value and so on and so on. So again, the key idea is to identify the the number of periods, and of course the rate per period is very key to us. And then we just do a walkthrough, identify the number of periods and the rate, and walk through the intersection of the two is where the future value interest factor is, and we use that value to multiply with the present value, and that will give us the future value. Vice versa, if you are looking at the present value, uh, present value, then you end up using a different table. And I'm going to show you this later on, but you end up using a different table to determine, of course, how to use the present value table. So this one will be the same table, but it's going to be a different table that you have to pick up the value from. And I can just show you quickly your present value table will be different, and this is what you're going to have. So I'll pick up from there and continue to show how to use the present value table and how to compute the present value using the same table, and of course using other methods. And then of course later on I'm going to point or pick up some other examples. Hope this information helps, and I'll be doing a second part of the video and a third part of the video just to illustrate some of these points. Thank you.